Hello, we are now going to finish up circuits with capacitor circuits 4.7. So if you haven't done the reading, please do it now. Go to Coletta, go to chapter 18, go to section chapter 18, part dash 2 of that, read that part. Also chapter 19 and chapter 20. Also, homework 7, circuits, please finish that up. And if you're in Physics 112, do just the circuits homework. All right, and we will be doing lab 8 work today. So we've been talking about capacitors this entire time, and when we were in the voltage chapter, there was some readings there in chapter 18 of Coletta on capacitance. All right. So again, a capacitor will build up negative charge on one plate, and what will happen is positive charges will build up on another plate. Will already be there. It's just the electrons are moving. Well, anyways. Which will happen, when electrons build up on one plate, you have positives right here, and that makes a homogeneous electric field pointing in one direction, right? Well, that electric field is due to charges. So you have Q's, which are charges, and we're going to say this, that I'm going to mark up this document a little bit. So I went to the comments area, and now I'm going to put on a little pencil. And so Q is charge, and that when we're doing our worksheets, we're going to call that, we're going to be using microfarads for that. Okay, and that's the unit of, actually, not microfarads. I'm sorry, just microcoulombs, right? Normally, the unit of charge that you deal with is just a coulomb, right? But in our worksheets, we're going to be dealing in microcoulombs. So the voltage difference between the two plates is just the potential difference, also known as voltage, and that unit is appropriately a volt. Okay. So putting these two things together, what you find out is you have this new type of measurement called capacitance. And that unit of measurement that we're going to be dealing with, normally it would be in farads, right? But in our worksheets, we're going to be doing it in microfarads. That's 10 to the negative 6. Micro is 10 to the negative 6. Also, micro, little fun fact, it's right here. Let's draw it so it's nice and cool looking. Micro is the Greek letter called mu. It's lowercase m, called mu, and it's the Greek letter for kitty cat. All right? That last part isn't true. It's not the Greek letter for kitty cat. It's just a Greek letter for lowercase m. But anyways, I like it. It looks like a little kitty cat, so that's what I'm calling it. All right. So, how is a capacitor charged? Well, electrons, so how did capacitors build up charge on something, right? So, electrons can freely move, right? And so these electrons, so the current is flowing from positive to negative that we learned, okay? But what happens is electrons are leaving this, is basically being pushed, are in this wire, are being pushed here. And what happens is the electrons are building up here. Any electrons on this plate are going to be on this plate now. And so what you find out is this plate, just whatever protons that were stuck here in the metal, there, have now lost all of their electrons, and they're now building up over here. So what you have is just a plate of protons, and you have a plate of electrons over here, okay? Which then just naturally creates an electric field. Electric field points away from a positive and towards a negative, right? So the electric field is going to be pointing up and equally spaced. It'll be pointing from positive to the negative, right? Well, that is what a capacitor does. That's its job, okay? Again, the unit of, we're going to be dealing with Q is equal to capacitance, so charge is equal to capacitance times voltage, or what you could also say is capacitance is equal to charge over voltage. And another thing that you could say is this: voltage is going to be equal to charge over capacitance. So if you ever see a capacitance in microfarads right next to a voltage, multiply those two things together when we get to the worksheets. Otherwise, you're going to take microcoulombs and divide it by voltage, or microfarads, or microcoulombs divided by microfarads, okay? So now that we're dealing with capacitors, you have to reapply the Kirchhoff's rules, right? And I'm hesitant to rewrite these rules in terms of charge, but they really do mean the same thing, right? So back in this wire, the Kirchhoff's rules were originally talking about current, right? Actually, it might be better if I just do this in a PHET simulation. So let me go to the PHET simulation and I'll show you what I'm about to talk. So we have to readjust these Kirchhoff rules, right? So we just learned the relationship between charge, capacitance, and voltage. But Kirchhoff's junction rule still is dealing with the current in is equal to current out, and the loop rule is the voltage being produced by the batteries, the voltage being consumed by the resistors, right? But how do we change this one is problematic. So how do we take this and turn it into the same thing? Well, I'm going to go back to where we started, and why do we have to change our rules is more of the question that I want to talk about. So let's make things visible. So I'm going to allow the electrons, actually I'm going to put a resistor into place. Do we have anything else? We don't have a capacitor, do we? That would be great. Of course we don't have a capacitor. All right, well, let's just use a light bulb that we normally used. And we'll talk about why we're talking about charge. And how are we going to adjust the Kirchhoff's junction rule when it's dealing with current, and how we're going to be applying it to charge, right? So notice that these little vectors are the current, and it's flowing from positive to negative, right? Well, if you notice again, the current is flowing away from the negative end, and if this were a capacitor, these electrons would be building up on the plate here. The negative plate would be on this side. The positive plate would be on the right-hand side, right? So to that effect, in the electrons moving in this wire, again, that's the drift velocity of the electrons. And so basically, since current is the electrons, just in the opposite direction, what we could do is apply the junction rules as if we're dealing with the actual charges. And what I'm talking about, oh, why does it do that all the time, is this. Basically, the charge building up on one plate, the charge flowing into one area is going to be distributed, so the charge in is going to be equal to the charge out, right? That can be said, since charge and current are essentially the same thing, right? We could, just in opposite directions, we could actually apply this junction rule and just, instead of talking about current, just think of it, current is charge, right? So it's the same thing. The charge into a junction is equal to the charge out of a junction, all right? And that what that would say as a consequence is that if you know, and this should be series, and this should be parallel. Sorry about that. If you know the charge across two, if you have two components, two capacitors that are in series with each other, and you know the charge on one of them, then you know the charge on the other one. And here, the Kirchhoff's rule still hasn't changed. If you know the voltage, if you have two capacitors or a capacitor and a battery that are in parallel with each other, and you know the voltage on one of those, it's the voltage on the other. Here's a weird thing, though. If you have two capacitors that are in series with each other, that is equal to the product over the sum of those capacitance values, right? With resistors, remember how it was, you have the equivalent resistors, they have two resistors that are in series with each other. It was this. This is actually the complete opposite, right? When you had two resistors that were in parallel with each other, you would have product of those over the sum, right? Well, in this case with capacitors, you're just adding those two capacitors together. So the rules are really kind of opposite when we're talking about capacitors, okay? Again, keep in mind that we're going to be dealing with these puzzles, that this is going to be a microcoulomb, capacitance will be a microfarad, and voltage will just be voltage. Essentially, here's what if you ever see a microfarad next to a volt, multiply those two together in these puzzles. If you see, other than that, if you see a microfarad and a voltage, okay, multiply it. Otherwise, divide the big number by the small number, so long that it becomes a whole number, and that will be the voltage or the capacitance that comes out of that division, okay? So let's try something. Let's go ahead and do a puzzle. So this is Capacitor Circuits 1, 3.6. Here we have another cute kitty. I haven't stopped that theme. I will never stop it. What I want you to do is I want you to go ahead and try this puzzle, all right? Keep the rules in mind and try the puzzle out, okay? So pause the video and try everything, and what I'll do afterwards is I'll go ahead and I'll do it myself and talk to you about it. So take a break and pause. All right, we're back. Let's go ahead and try this. So we're going to be dealing with these rules right here, and I'll try to, I suppose I should write the rules here. Rule number 1 is Q is equal to C times V, right? Rule number 2, we'll just write the consequence. If two capacitors are in series with each other, then that would be then the charges are equal, okay, on each capacitor. If you have two capacitors that are parallel with each other, or capacitor and a battery that are parallel, then the voltage is equal. Okay, so that's a quick, easy way to do this. So Well, let's go ahead and talk about the problem. You have a battery right here. You have a capacitor that is in parallel with the battery. B and C are also capacitors, and they are in parallel with the battery, in parallel with this branch too. So B and C are in series with each other, but they're in parallel with A and the battery, and also they're in parallel with D, this branch, D, the DE branch, while D is in series with E. So let's try to do some things. Let's start in order. Let's see if we could apply Rule 1. That means we need 2 of the variables right here. Well, I have 16 microcoulombs. Well, that is the charge. So that's a Q. And this is 2 microfarads. That is capacitance, right? This is going to be a little weird for you guys because you see a microcoulomb right here, and you're going to think that is a capacitance. It's not. Capacitance is a microfarad. Okay? So 16 microcoulombs divided by 2 microfarads, right? So Q divided by C is equal to voltage, right? Well, that is going to be 16 divided by 2. That is going to be 8 volts. So you know this guy is being powered by 8 volts. It's consuming 8 volts of the entire 12 volts here, right? B and C are in parallel with the battery. Let's continue on with rule number 1, and we'll worry about the rest later. Here we got 18 microcoulombs. Again, we have charge, and we have 2 microfarads. 18 divided by 2, 18 microcoulombs divided by 2 microfarads is going to be 9 volts. Okay? That Q and C are confusing to me, so I'm going to get rid of those. Alright. So here we go. Let's talk about this. Okay, so we did rule number 1. Let's try to do rule number 2. We're going to look to see a Q, or in other words, a microcoulomb. If we see a capacitor that is in series with another one, and we see a microcoulomb on one, then we'll know the microcoulomb the other. Well, B is in series with C. And this has 16 microcoulombs. Therefore, C has to be 16 microcoulombs. Okay? Not only that, D is in series with E. D has 18 microcoulombs, so E must have 18 microcoulombs as well. All right. Can't do much more. We've gotten B completed and D completed. We can't do anything more with C, E, and A unless we go to rule number 3. Rule number 3 is this: the voltage in one branch is equal to the voltage in another branch, and the voltage in another branch, and the voltage. So all these guys, the battery is in parallel with A. It's also parallel with the BC branch and parallel with the DE branch. So if this is 12 volts, the loop rule states that this has to be consuming that 12 volts, right? And what have I always said? If you've got the voltage of one thing, if you've got two of the variables, quickly just solve the thing, right? So here we have voltage and a microfarad. Do you multiply these two or divide them? What do you think? Well, microfarad is capacitance and voltage is voltage, right? So you're going to have to multiply them. That means right here that this has built up 12 microcoulombs of charge on it. 12 volts times 1 microfarad, 12 microcoulombs. All right. Let's try this branch. BC branch needs to equal 12. Okay, but 8 of that 12 is there. 8 of that 12 is wrapped up with B. That means the rest of the 12 is in C. So this is going to be 4 volts, right? Well, now we have microcoulombs. We have 16 microcoulombs, which is going to be charge. And we have 4 volts, which is voltage here. So that means this is going to be capacitance, right? 16 microcoulombs divided by 4 volts is going to be 4 microfarads. All right? So this 12 volts is here and is parallel with the DE branch, okay? We've done everything we could with D. That's completed. So this is 12 volts, is parallel with DE. So this DE branch has to add up to be 12 volts. Well, we know 9 of that 12 volts is there, so the other 3 volts have to be here too. Okay. Well, again, we have microcoulombs divided by voltage. That's going to give us the capacitance in microfarads. 18 microcoulombs divided by 3 volts is going to be 6 microfarads. Awesome. The interesting thing, batteries don't have any charge or capacitance associated with them. They're just a battery. So you don't have to do anything more with the battery. All right. Well, now that I've got that done, I'm going to go ahead and start filling in stuff. The voltage here is 12 in A, and the charge is 12 microcoulombs. Okay? And I put MC here, and I should make that micro. Okay? And I'll do that right now. Hold on a second. Actually, I'll do that after this. All right, so I guess what I'm saying, sorry, I should clarify what I'm saying. I just noticed that this is MC, and this should be micro C, and this should be microfarads. Sorry about that. Let's do B. So B is got 2 microfarads. Okay, its capacitance is 16 microcoulombs. And that is 8 volts. C is right here. C's got 16 microcoulombs. It's going to have 4 volts, and it's going to have 4 microfarads. D's got 2 wow, I've got that backwards. This should be 18, and this should be 2. Wow, I've got to fix that. I'll fix that in your notes so you don't see this. But this should be, come on, this should be 18, and this should be 2. So D is going to be 9 volts. E is going to be 3 volts. 18 microcoulombs and 6 microfarads. And there is no F. So I'm going to take this out too. Okay? So F is just blah, blah, blah. I'll fix that up on the next one. Let's move on to the next slide. So here we are on the next problem, and this is Capacitor Circuits 1, 3.6. So what we're going to do is I want you to go ahead and take a shot at this now that you've done another problem with me. So go ahead and do this. You have a battery that is in parallel with this entire branch right here. This is A. You've got those 2 variables here. B and C are in parallel only with each other. D is in series with this sub-branch as well as an A, and E, F, and G are all in parallel with each other, and they're all in series with all of these other components. All right, so go ahead and try this, and let's see how you do. Pause the video now. All right, well, let's go ahead and go to the comment area. And I'm going to go ahead and mark up this document, and let's see what we could do. Again, since this is kind of new and we're practicing, I'm going to write out the rules, right? Q is equal to CV, And while I'm here, I'm just going to write Q over C is equal to V, and Q over V is equal to C. Okay? And okay, and it was just making sure I had that written right. What I'm also going to do is say two things in series. If you know the charge on one, then you know the charge on the other. And really, the loop rule hasn't changed. If you have two elements that are in parallel with each other, the voltage is equal. Okay, so go ahead and let's get started. So I'm looking at this and I don't know what to do instantly. And when I feel like that, what I do is I stick to the rules and I try to go in order of the rules. So let's try it. Number one is Q is equal to CV. So basically, to apply rule number one, I'm going to need two of the variables. Well, I have two of the variables in A. I have 12 volts and I have 3 microfarads. So I have a voltage over a coulomb, over a capacitor, right? So voltage, I have voltage and I have a capacitance. So I'm going to have to multiply those together to see how much charge this is getting. So this is going to be 36 microcoulombs, right? Charge, Q, is microcoulomb. Okay. Well, now that we're here, we could actually start tracing the junction. This 36 microcoulombs is going to come in, and what's going to happen is part of that 36 is going to come down to here, and what it looks like, that is going to be 12 microcoulombs. Okay, so red is going to be 12 microcoulombs. So what black is going to split off, and it's going to split off into another one, right? So blue. So blue is going to then go across this, the amount of those charges. The rest of that 36 that isn't 12 is going to go over this way and go across, and then it's going to become black again. Okay? So 36 is coming in, 12 is going down here. How much is left over? Well, 24 microcoulombs, right? So we know that 24 microcoulombs plus 12 microcoulombs is going to be equal to 36, right? Well, now, the beauty of this is, now we're going to know the voltage, right? 12 microcoulombs divided by 2 microfarads. I'm doing B right now. 12 microcoulombs divided by 2 microfarads. Well, that's going to be 12 volts, right? And since B is in parallel with C, well, we know that is also 12 volts too, right? And now we know that we have charge, which is 12 microcoulombs divided by 12 volts. Well, that is going to be the capacitance, which is going to be 1 microfarad. Okay? Okay. So now we get to this point, and now blue and red have joined up, and we know that this is 36 microcoulombs again, because 36 split up, and then it has to join back up, right? Well, we don't know much else from here, but what we do know, we could actually try to extrapolate from E, F, and G, right? So E, F, and G are all in parallel with each other, right? And if they're in parallel with each other, I'm going to start looking for a voltage. Well, I see a voltage right here. So that means this has to be 2 volts, and this has to be 2 volts. They're all equal in voltage, right? And now I have a microfarad, and I have a voltage up here in E. Well, 6 microfarads and 2 volts, that's going to be 12 microcoulombs, right? Well, I'm going to use a different color. I am going to use green. That means green is coming up, and that 12 microcoulombs is coming to the right, then heading down back to this junction. So we know part of that 36 microcoulombs, that 12 microcoulombs is going in there. Okay? Well, can't do much else with all of this. Well, now what we can do. Okay, well, let's think about it. We know this entire branch is in parallel with this. So that means if this is 30 volts, this whole thing needs to be 30 volts. Well, we know the voltage here, that's 12. And although B and C are in parallel with each other, that doesn't mean that you go, this is 12 volts and this is 12 volts, so that's 24 volts. Well, stuff in parallel, that's just the same voltage. So this only counts for 12 volts. 12 volts plus 12 volts is, now we're at 24 volts. This branch is only 2 volts, so that's going to be a total of 26 volts so far. So to get D, we're going to have to subtract 30 from 26, and because 12 plus 12 plus 2 is going to be 26, and that's going to get us, what is that? What is 30? Put that, put a 10 up here, and we just get 4 volts. So E has to be 4 volts. That means this is 4 volts right there. Okay? And what that tells me, now we have the, in order to get the capacitance of that, we have charge, we have voltage. Now we get the capacitance of this, which is going to be 6 microfarads. Now here's where we have a problem, right? Mark Summers does these wonderful puzzles, and in this case, I think Mark is trying to teach us a life lesson again, and say that sometimes these problems can't be solved. Well, I'm not accepting that. I'm sorry, Mark, if you're listening. I'm going to go ahead and I'm going to just say this. I'm going to go pink here. Actually, I'm going to stay back in black, and I'm going to, what did I do here? I did nothing. Okay. I'm going to say this. I'm going to say we also know that this is 6 microfarads. Okay? And if that's 6 microfarads, this is 6 microfarads. And that means it's going to be 12 microcoulombs and 12 microcoulombs according to this. I have to solve it. I have to have an answer. And let's just say this is all equally distributed. So this 36 coming in, 12 bits here, 12 bits here, and 12 bits here. Okay? And now we have a solved puzzle. So I'm going to go ahead and put in my answers here. Let's start with A. A is going to be 12 volts. The capacitance is going to be 36 and 3. B is going to be 2 microfarads. The voltage is going to be 12 volts. And the charge is going to be 24 microcoulombs. C is going to be 4 volts. The capacitance, the charge is 12 microcoulombs, and the capacitance is 6. D is going to be 4 volts. The charge is going to be 36. Oops, 36. And the capacitance is going to be 6 microfarads. Okay. This should be a 1. C should be 1. And this should be 12. Okay, just trying to make sure. Whoops, I made a mistake when I was copying that down. I apologize. All right. E is, so E, F, and G are all the same things. They're all going to have 12. That 36 is going to be 12. This should be 12 as well. I don't know why I have a 3 there. I'll fix that. This should be 12. Whoops, this should be 6 microfarads. 6 microfarads. Okay. And this should just be 12. So I'm going to write that in here. Now, I'll fix it in your notes, but this has got to be 12. Okay? I don't know why there's a 3 there. Okay? And now we have a solved puzzle. Please move on to the next page of this, and we'll get started. And here we are on the very last puzzle for this lecture. Okay? This is in Capacitor Circuits 2, 3.7. Okay? And what that means is this. When we're writing our rules, and I'll write them here. Q is equal to CV. Q over C is equal to V. Q over V is equal to C. Means rule 2 is going to actually have 2 parts to it. If you see 2 capacitors in series with each other, the charge is equal. And what that also means is that if you put 2 capacitors together, that's the product of the 2 capacitors or the sum of the 2 capacitors. Rule 3, if you see 2 capacitors in parallel, then the voltage is equal. And that if they are in parallel and you want to add those together, you want to put those 2 capacitors together, it's just like adding them together. Okay? So let's go ahead and try Capacitor Circuits part 2. So go ahead and attempt this puzzle, right? You know enough about these puzzles to figure it out. Right? Pause the video now. Okay, here we go. So what we have is we have this entire branch. This entire branch up top is in parallel with this, or this battery is rather powering the entire branch, right? A and B are in series with each other. This sub-branch AB is in parallel with C, and C is in parallel with D. Okay? This whole branch is in series with E, and E and F, F and G are in parallel with each other. Okay? So let's go ahead and start with the rules. I don't know how to start on this one, so I'm going to start with rule number 1. I'm going to look for a capacitor that has 2 of the variables. I don't have any, so I have to move on to rule 2. Rule 2, that means if I'm going to look for 2 capacitors that are in series with each other. And if I know the charge on one, then I'll know the charge on the other. Well, A, we know the charge on that. That's 4 microcoulombs. That means we know B, which is also going to be 4 microcoulombs, right? And now that we have microcoulombs, 4 microcoulombs, and 2 microfarads. Well, now we know the voltage. That is going to be 2 volts. Okay? So now I'm going to move on. I can't see anything else that I could do in this other stuff. I'm going to move on to rule 3. I'm going to look for stuff that's in parallel. A and B, branch AB is in parallel with C and also in D. And we know C is 6 volts. What that tells me is that D is also 6 volts. And since I have voltage and I have capacitance, 6 volts times 6 volts times 2 microfarads is going to be 12 microcoulombs. Okay. Cool. All right. Well, this guy right here, we know the voltage here, that's 2. And that means A and B added together needs to be 6. That means this has got to be 4. And now we know the voltage there. That's going to be it's going to be 4 volts, and we have 4 microcoulombs. So 4 microcoulombs divided by 4 volts, that's going to be 1 microfarad. All right. Well, let's move on. So now we have that. We have to start thinking now if we're going to get the capacitance through this. Okay. Well, we know 22 microcoulombs is going through there, right? And we know 4 microcoulombs is going across these two guys. And we know that, oops, I changed that one too. Sorry about that, I'm having some technical issues. I'm trying to change colors. It's not letting me do it. So I'm going to have to try to draw this in red. So blue is going to be 4 microcoulombs. Well, we have 12 microcoulombs going through D, right? So this is 12 microcoulombs coming in there. Come on. I don't know why it's acting so weird. And we have 4 microcoulombs going through there, right? So now we have a charge, we have a mounted charge going through the 6 volts, and we're going to call it green. So 12 microcoulombs going up, joining up with 4, are going to be equal to 22. Well, whatever green is, it's going to be 22 minus 12 minus 4. So 22 minus 16, what is that? 4 plus 2, so that is 6 microcoulombs, right? And so now I'm going to change this back to black. And so 6 volts divided by, 6 microcoulombs divided by 6 volts, that's going to be 1 microfarad. Okay. And now we have this entire part completed. Okay. In order to do this other part, to get the rest of this, we're going to have to combine these two resistors together. These two capacitors together. Well, they're in parallel with each other. Well, if we put those together, and we'll get just one capacitor. So imagine we just have one capacitor right here, and it is 11 microfarads. Okay, 6 microfarads plus 5 microfarads, right? If they're in parallel, you add them. That is going to be 11 microfarads, right? Well, that 11 microfarads is getting 22 microcoulombs. And so let me pop that back out, and I'm going to do this math over here. That's going to be 11 microfarads, 22 microcoulombs. Well, 22 microcoulombs divided by 11 microfarads, well, that's going to be 2 volts, right? And so whatever this guy is right here, that would be getting, that 11 microfarad capacitor would be getting 2 volts. Well, now we know if that is 2 volts, that means those two guys have to be 2 volts as well. So that means that this is 2 volts, and this is 2 volts as well. And since we have voltage, right, we have a voltage and we have a capacitance, 2 volts times 6 microfarads is going to be 12 microcoulombs. 2 volts, 5 microfarads, 10 microcoulombs. Well, now we have the voltage here, right? The whole branch needs to be getting 10 volts. 6 of that 10 is here. 2 more of that 10 is here. And what that means is that is an 8 total. Well, this has to be 2 volts as well as this. So 2 volts plus 2 volts. This whole thing is 2, 6. That adds to 10. Cool. Well, that's going to work out to be 11 microfarads. Is that guy. All right. And now we have it completed. And we could actually start putting in our answers. The voltage here is going to be 4 volts. I don't know why this. I think some things got shifted when I converted this document. This should be, no, that is 4 micro capacitance. Okay, good. And this is going to be 1 microfarad. Okay, cool. Well, B, we have 2 volts, 4 microcoulombs, and 2 microfarads. C is going to be 6 volts. It's going to be 6 microcoulombs and 1 microfarad. D is going to be 6 volts. It's going to be 2 microfarads, and it's going to be 12 microcoulombs. E is going to be 2 volts. It's going to be 22 microcoulombs, and it's going to be 11 microfarads. F is up here. It's going to be 2 volts, 12 microcoulombs, and 6 microfarads. G is going to also be 2 volts, and 10 microcoulombs, and 5 microfarads. All right? So that concludes all of capacitance circuits, part of the circuits. So I hope you had fun doing these puzzles. I really enjoy Mark Summers' puzzles that he put together, and they're really great. So please work on your sapling homework and try to get that done. Okay? Thank you very much. Bye.